Problem number 2 on the spring 2015 exam is just asking you to evaluate the integral. So it gives you 1 minus 2x over x squared times x minus 1 with a dx. And it gives you 5 different options for the answers, and then with a plus c. So let's take a look at this. Let's see if we can figure out how to solve it. So one thing I notice is that I do have an x squared and an x minus 1 on the bottom. That shouts to me partial fraction decomposition, mainly because I know that I can split these into linear roots that I can use to solve for the a, the b, the c of partial fractions. I also noticed that there's no natural log or trig functions in that case, which might screw up the partial fractions. It looks like I just have like a pretty easy linear term on top. So I think partial fractions would be a good way to go about this. So what I'm going to do is I'm going to go ahead and write out the partial fraction split for this problem and see how it works. So I have x squared times x minus 1. X squared is not a polynomial term, it's a repeated linear root. So that means that when I write this out, I have to write it as a over x plus b over x squared. Then this term, that has its own little term associated with it, and that's just c over x minus 1. I have 3 terms. Now what I need to do is I need to apply partial fraction decomposition and solve for a, b, and c. So when I look at this, this repeated term is going to give me a little bit of trouble. I can use cover-up method to solve for one of the terms, and the only term I can solve for is the highest power term. So if I'm splitting stuff with partial fractions and I have a repeated linear root, the only term I can use cover-up on is the highest term. The other term I have to use something else to solve for it. This term, though, I can definitely use cover-up method to go ahead and solve for it. So b and c can be solved for right away, and that just leaves us to solve for a later on. So let's go ahead and let's apply cover-up method to a, b, and c. So just to b and c rather. So if I go ahead, if I have x squared, I'm plugging in x equals 0 to solve for that. When I cover it up, and I cover up over here, if I plug in 0, I end up with 1 over 0 minus 1, which tells me that that should be negative 1. So that tells me that b is equal to negative 1. Do the same thing for c. c, I'm plugging in x equals 1. If I go ahead and plug in x equals 1, I cover up here and I cover up here, and I plug in, I end up getting 1 minus 2 over 1 squared. So that becomes 1 minus 2 is negative 1 over 1 squared is positive 1. So c is also equal to negative 1. So I have b and c, but to solve for a, what I'm going to have to do is I'm going to have to actually factor out my terms and multiply through to solve for a. So what I can do is, in this case, I have a, b, c. I have 1 minus 2x over x squared, x minus 1, and I can create my little system. So again, what I'm trying to do here is I'm trying to get all these terms to have the same denominator, so that way I can multiply it out. So I have a, I need to multiply by an x and an x minus 1 to be able to get x squared, x minus 1 on the bottom. Because remember, I can only ever multiply something by 1. So if I multiply by a term on top, I have to do the same thing on the bottom. But now this has the same denominator. B, so for b, I have plus, and I already know what b is actually, so I'm going to go ahead and just write that as a minus sign. So that's minus 1. I have an x squared, so I'd be missing an x minus 1 term. And now on the bottom I have x squared, x minus 1. And what I'm going to do is I'm just going to go ahead and make this minus sign in the middle of these terms. So now we have a and b. Now we're looking for c. So to find what c is, well, we already know what c is rather. So I'm just going to write a minus sign here again. I have an x minus 1, so that means this needs to be just x squared over x squared, x minus 1. So now we've gotten all the terms to a common denominator. So what I can do is now I can add these terms together and I can go ahead and cancel out the denominators for all the terms. What I'm left with is I'm left with 1 minus 2x is equal to, so if I go ahead and distribute this out, this is ax squared minus ax minus x plus 1 minus x squared. So I can do this one of two ways. What I can do is I can group them according to their power. So in this case, I look over here, and if I go ahead and organize them a little bit more, I have a minus 1 times x squared. I then have a minus a minus 1 x, and then I just have a plus 1 by itself. So if I want to solve for a, I need to pick one of these terms and equate it to what it is on the other side. So what I'm doing here is I'm basically saying that if there's a minus 2x over here, this needs to be minus 2x for these to be equal. Because if this is an equation, this side needs to be equal to this side. So whatever a is, it has to work out so that I have the same minus 2x plus 1 and no x squared term. So what I'm going to do is I'm going to take this minus a minus 1. I'm going to equate it to minus 2. So I'm equating this to this. And now what I can do is I just have one equation, one unknown. I can solve that equation. So if I add 1 to here, I end up with minus a equals minus 1. So that means that a is equal to 1. So now I've gone through and I've solved for b and c. And I've also solved for a. So I can go ahead, I can write this integral back out, and now I can solve for it because I know what a, b, and c are. So what I end up getting is I end up getting 1 over x minus 1 over x squared minus 1 over x minus 1. And these all have integral signs in front of them. So now when I go through, because technically these all have integral signs in front of them, I just don't write them out when I write my partial fraction decomposition. Now I can go through and I can just integrate them all. So if I integrate this term, I end up with natural log of x minus, when I integrate 1 over x squared, that has a second power on the bottom. So if I bring it up as a negative power, I have x to the negative 2. If I add 1 to that and divide by that new power, I end up getting positive 1 over x minus natural log of x minus 1. And of course, we always add plus c if it's indefinite. So when I look at the answers, the answer should be letter E, which is natural log of x plus 1 over x minus natural log of x minus 1, and the plus c is already written in the answer. So this is the correct answer, and that corresponds to letter E.
The Teaching Center, UF's Learning Resource Center.